that, we are ready for our next talk. And up next is Patricio. And Patricio is going to be talking about Hardhat present and future. Super excited to see what he has to share and announce today. Welcome.
Hey, thanks, Kartik, for the introduction. So let me just set this up. Okay, can you see my screen? Yep, right. Okay, thanks everyone to be somewhere watching at this presentation. So I'm Patricio, co-founder and CTO of Nomic Labs, and you probably know us from our product, our development tool called Hardhat. In this presentation, I'm gonna talk about how Hardhat works internally and its future. So first, a quick recap about what Hardhat is. Hardhat is an Ethereum development environment, which is composed by two major components. One is Hardhat Runner, and the other one is Hardhat Network. Hardhat Runner is a task runner that lets you automate all the common tasks that you have to do while developing Ethereum applications. There are similar tools to Hardhat Runner in every development ecosystem or platform. For example, Webpack and Parcel are some of the most common ones when doing web development, or Gradle when doing Android development. And actually, Hardhat Runner has been heavily inspired by this. By default, Hardhat Runner comes with a set of predefined tasks that let you do things like compiling your contracts, testing them, deploying them, things like that. But there's also a rich ecosystem of plugins that let you integrate other tools, add features or new tasks to Hardhat Runner, or customize the existing ones. Hardhat Network is our development Ethereum network. And what this means is that it simulates an Ethereum network, just like Mainnet, Ropsten, or Koban, where it's totally local. Instead of having many nodes communicating with each other, you can think of Hardhat Network as a single node, ephemeral Ethereum network. When you run Hardhat Runner, just like running your tests, a new instance of Hardhat Network gets initialized. Your smart contracts are run within Hardhat Network, and then after your tests passed or failed, this instance of Hardhat Network gets destroyed. And in this presentation, we are going to focus on how Hardhat Network works, the challenges of building and maintaining it, and how it's going to evolve in the future. So first, how does Hardhat Network work? Hardhat Network is a Node.js module that it's embedded into Hardhat Runner and exposes the same JSON RPC interface that a real Ethereum node does. This means that we kind of lie to the different libraries and applications that integrate with Hardhat Network and pretend to be a real node, but instead do everything locally within Node.js. So for example, when you connect MetaMask or other wallet to Hardhat Network, it doesn't need to know that it's dealing with Hardhat. Instead, it just acts as if it were working with Ethereum mainnet. The same happens with Web3 or Ethers or any other library or application. This gave us the advantage of being able to integrate with everything quite easily. So instead of communicating things to a network, Hardhat Network resolves everything locally. And what this means is that if you send a transaction, we don't forward it to a network of different nodes, but just create a local block in our own blockchain and keep it for us. We don't forward those blocks either and not communicate with anyone else. And to do this, we use Ethereum JS VM, which is a TypeScript EVM implementation, and it lets us execute everything locally. But what made Hardhat Network different or special is not being able to simulate a network, but rather that we always look or try to provide as much context and information about what's going on with your smart contracts, because that's what lets let developers debug and test their smart contracts and be more effective on building them. And this is where automation challenges appear. And the way this works is by relying on runtime observation. And this is because in Ethereum, as we all know, you have to pay for gas when you try to execute something. And in particular, the person paying for that gas is the final user. So keeping the amount of gas that you pay to a minimum is super important, because it makes your application more or less competitive. And this leads to many things, but in particular, one of them is SolC generating a minimal amount of bytecode when compiling your smart contracts. Instead of embedding functionality to help you debug your smart contracts or help tools do that, it has to output a very minimal bytecode without any kind of runtime support, so that the amount of gas that the final users are going to pay when running that smart contract is lower. So things like, for example, generating stack traces are not part of the program, but rather left to the tooling. In contrast, in other development platforms, this will be embedded within the actual binary, which makes things easier because the compiler has the whole controller information to be able to do this effectively. But the way we approach this is instead by, as I mentioned, runtime observation. But what does that mean? It means that when we execute anything within Hardhat Network, we trace this execution. And by tracing here, I mean collecting information or the history of what went through when executing the contract at the EVM. And this trace, you can think of it as a sequence of EVM opcodes or operations that have been run during the execution of a given smart contract. And while this is very useful at that level, it isn't very approachable, because you have to be very deep into the EVM to be able to understand things at that level. But instead, what we do is take that EVM and very low level representation of the execution of your contract and try to recreate more friendly information for the user. For example, this is how we implement console log. When we take a trace of the EVM, we recognize certain patterns that mean that someone tried to call to the console log library or function. And when we detect that, we decode the calls arguments and print them to the console or to the terminal of the user. And this is in general the approach that you have to take if you are willing to build advanced tooling for Ethereum. Another thing that we do is generating stack traces. And in this case, it's similar. Like we take the trace, an EVM trace, but also fetch the compiler's output that has a lot of information about your contract and combine those to recreate a call stack in Solidity, which means that we know when a function was called or a return from a function was executed. But this is not always complete or perfect, because there are certain ways that a contract can fail or certain paths of execution which are not actually reflected or come from your code, but rather from internal Solidity functionality or auto-generated code. And that information is not very useful for the final user or developer. And this is particularly true for all the versions of Solidity. So what we do is relying on a set of heuristics that we built through time to improve this information and give richer things to the user, like auto-generated error messages. When you send, for example, when you send a transaction to a contract and the function that you are trying to invoke doesn't exist in that contract, we can detect that and give a clear error message explaining what it did. While depending on the version of Solidity and your settings, without this set of heuristics, all you would have got is a revert without reason error message. And this is, in fact, a ton of work to build and has some limitations that I'm going to explore next. The first one is that relying on heuristics is extremely fragile. They are built super ad hoc for every version of Solidity. In fact, the way that we build them is by looking at hundreds of EVM traces, and after some time you start to recognize patterns between them, and then encoding those patterns within Hardhat Network. So we can kind of translate our intuitive like pattern matching that we do when looking at these EVM traces and encode it as JavaScript code within Hardhat Network. But the problem is that as they are super ad hoc, they are fragile, because whenever a new version of Solidity comes out, they can break, because maybe Solidity changed something that broke our pattern. It doesn't repeat anymore. And the change may make sense. It's not their responsibility for our heuristics to be stable through time. But the problem with that is that nothing guarantees us that we will be able to fix them, or that we will be able to create new ones if we need them for a particular feature. Another problem with them is that they are not always accurate, because these are heuristics, and for the ones on the audience that don't know what that means, you can think of them as fuzzy matching things. In this context, at least, they are like pattern recognition logic, but not very precise. And the reason that they are not very precise is because they can't be too precise, or we are going to have a lot of false negatives, and they can't be too loose, because otherwise we are going to have false positives. But we'll never be able to be 100% accurate, because the compiler doesn't give us the precise information to do that. Another problem with this approach is that the tooling that does this is always getting more and more complex. The reason for this is that Solidity versions tend to stick forever within the ecosystem. Let's suppose that you build a contract now. You probably are going to use Solidity 0.84 or 0.85, something along those lines. And tomorrow and you finish your contract, you deploy it, and tomorrow 0.9 comes out and has some cool features that let us, tool developers, improve your development experience. The chances of you porting, rebuilding, and redeploying your contract just to get better tooling are very low, because that's gonna cost a lot of money, at least for audits. And also it's gonna take a huge coordination effort. And while the advantages for you may be huge, it's not great for the community. They won't get a lot of advantages. So that's not gonna happen. But even if you are building with the latest version of Solidity, chances are that you are interacting with a contract that was deployed using an older version of Solidity, and you still want to understand what and why things go wrong while you are testing your contracts or debugging them. So that means that we still need to support every version of Solidity, probably forever. Another disadvantage is that creating these tools is very expensive and complex. And this leads to two things. The first one is that there are fewer tools than maybe there would be if these were cheaper. And the other disadvantage is that you get very inconsistent features across the different tools. For example, if you want to use console log today, there's only a few tools that support it, like Hardhat. If you want a step debugger, there is just a few that have them. If you want to use a good integrated fuzzing system, there is just a few of them. And the problem with this is not that we want to have every feature that everyone has, but that these are very basic features that in other development platforms are a given, and they should be a given for every tool in Ethereum. But they are not, and that's something that we are aiming to improve. Instead, I think tooling should be tools should be differentiating themselves with more specific functionality instead of the basics. And the way that we are planning to tackle these problems is with two new projects that for now we call Slang and Rethnet. Slang is a new Solidity compiler that is going to be built especially for tooling. And Rethnet is a library that provides a development network with all this rich functionality that Hardhat has. So, as I just mentioned, Rethnet is going to be a library for other tools to build on top. Rethnet won't be a replacement for Hardhat Network within Hardhat, but instead it's going to be its new core, and the interface of Hardhat Network will still be the same. It's being built as a platform, as a runtime observation engine that will let Hardhat Network be more stable, faster, and mature, but also will let other tools get the same functionality for free. It's written in Rust, so it can be run everywhere and distribute just as a normal library, like a C library. And also it's gonna be compilable to WASM so that it can be used in a browser. And things like Remix or Ethereum Studio can get all these features for free. It's gonna provide all the functionality that Hardhat Network has out of the box. And instead of relying in heuristics, it's gonna depend on Slang's output to have an accurate understanding of Solidity, of what's going on everywhere. So we are gonna be able to be precise on all the things that we do, but we'll also be able to do more stuff because we are gonna have the information to do those things. And once the basic functionality is mature and we have the common base for a development network, we are gonna work on more advanced tools, more advanced features that Hardhat Network doesn't provide today, like a step debugger, a gas profiler, code coverage analysis, and more. Slang is a Solidity compiler, as I mentioned, that it's gonna be focused on developer tools. This means that we won't be competing with SolC, but instead we will be focusing on development time of your smart contracts, but like orienting the compiler to be able to integrate with other tools and provide all the information that those need. But building a compiler is a huge challenge, and we think that SolC does a good job on building a compiler that it's good for running your smart contracts on mainnet, and we pretend to keep using it for that. So Hardhat and other tools that want to use Slang will build both with Slang and SolC and use each of those builds for different things. And of course, deploying with the SolC build. Slang is also going to have an integrated language server, which is a service that lets text editors and IDEs integrate with the compiler to gather like features that advanced editors have to support the language for free. Things like jump to definition, refactors, jump to references, things like that, kind of require a compiler to be built, or at least part of the compiler. And we think that having them integrated within the compiler is a way to have them, to build them reliably and keeping them up to date with the evolution of the language. So we are also providing that out of the box. It's also going to have APIs for different tools to be built on top, like exposing the parser or the type check system. And those things are going to allow things like reliable, fast, and up-to-date linters, formatters, and other things. And one of the key things of Slang, as I mentioned, is that it's going to generate all the metadata that Rethnet requires, not only to be able to avoid relying on heuristics, but also to let us iterate Rethnet faster. So if we want to do anything that is not possible with Rethnet, we can just tweak Slang a bit and generate more metadata. And the cool thing here is that as we are not gonna be deploying these these bytecodes generated by compiling these smart contracts, we can tweak what we generate so that we can enable everything we want within Rethnet. But maybe some of you are wondering on how reliable are things gonna be if we compile with one compiler during development and with another one when deploying. And that would be a great question, because if we use different compilers for these things, this wouldn't be as reliable as just using C. But one of the cool things about Ethereum is that it's a completely deterministic and isolated platform or execution environment that lets us do pretty cool things. If you have two builds of the same smart contract, but that were built with different compilers, but both of them did a good job, like translating Solidity to EVM bytecode, they should execute and give the same results. There's of course going to be small differences in gas costs and stuff like that, but in general, the modifications to the Ethereum state should be the same. If I execute an ERC20 transfer built in a smart contract built with Slang or built with Sol-C, the end result should be the same. So we are going to take advantage of this and build Rethnet in a way that can execute both versions of a smart contract at the same time. So instead of relying just on Slang during development, we are going to be building with both and executing with both Slang and Sol-C. We are going to trace both of them, compare the results, and use Slang to gather rich metadata of the execution and Sol-C to commit the changes that smart contract execution made to the Ethereum state. And in general, this should work great and let us have the best of both worlds. Reliable test results, because they are the results that the Sol-C version of the contract generated, and that's going to be the same ones that this contract would generate on mainnet. And at the same time, we are also going to have as much metadata about the execution as we need. And there's of course a chance that these results don't match, and this would probably be because some bug or immature aspect of Slang, but that wouldn't be terrible either, because at worst what would happen is that the development experience would degrade a bit on a certain transaction or smart contract, but we'll still be able to rely on our test results. So we won't be compromising on correctness or security of our smart contracts. So the current status of these projects is different for each of them. Rethnet is already under development. It's being built from the inside out of Hardhat Network. We are going to replace one module at a time and ship them as part of Hardhat Network. Probably we'll ship both at the same time initially and do something similar to what I already mentioned of executing two things side by side and comparing results to ensure the correctness of Rethnet before shipping it to production. And Slang is not being developed yet. We are building a team of compiler experts and doing some research and planning around it. But both should ship within the next year and will be shipped initially as part of Hardhat, and as they mature, they will be exported as libraries and independent tools for other libraries and tools to be able to rely on them and get all this functionality for free. And finally, our goal here for both for Rethnet and Slang is for them to become the building blocks of the tooling of Ethereum, like all the major tooling. And our objective is to lower the cost that I mentioned of building new tools and maintaining the existing ones, so that this leads to new and more mature tools for Ethereum ecosystem, and eventually for all of its users and protocols that build on top of it. And finally, if anything of this looks interesting to you, we are hiring both for Rethnet and Slang, also for Hardhat and other projects that I didn't mention here. So feel free to go to this link, nomiglabs.io/hiring, and take a look at our job listings there. And if you have any question, you can join our Discord, which is in our website, hardhat.org. And that's all.
Awesome. Patricio, it was a great overview. And I mean, that's such a massive overtaking that you're going to go into over the next few years. You talked about a lot of this is still in the works, and especially for Slang. My only kind of question is, how do you think about that, especially when Solidity itself is also evolving in parallel? What are some kind of things that you are thinking that should be kept in mind, and how do you kind of match the direction and the speed of the EVM ecosystem evolving?
Yes, I think that's a good question, especially about Solidity still evolving. I think that's like a common fact for every language, as that it's gonna evolve fast, and tools are gonna struggle to keep up with it, and we are already struggling to keep up with it. And these projects were made massive, are gonna make keeping up with it much easier for us and other tools. But also, as the ecosystem matures and gets bigger and has more tools and more stakeholders depending on Solidity, I guess the natural progression is for the evolution of the language to split apart from the evolution of the compiler and have some kind of governance over the language. But that's still to be defined in the future.
Absolutely. Obviously, finding this out in real time with everybody else is the challenge.
Yeah.
Anybody to know what this look like, but this is great. I think you already talked about how people can get involved, so check out hardhat.org, and if you're interested in being part of this future, apply to Hardhat. So thanks again, Patricio. This is great.
Thank you.
I wish you all the best, and can't wait to use Slang and Rethnet.